In this section, we're going to study polynomial and rational inequalities, and we're actually going to look at the polynomial inequalities first. So this next slide will have the steps that we're going to take. So you need to take just a few minutes to copy these down. A little bit more there at the bottom for you to see there too. Alright, what I'm going to do is just take you through these steps as I go through this first example, so I'll just be referring back and forth to these. Okay, so here's our first polynomial. Alright, going back to step 1, it said express in the form of f of x is less than 0 or f of x is greater than 0. Now, it could be less than or equal to or greater than or equal to. But you want to have 0 on one side, which that's already done here for us. Step 2 says to solve f of x equals 0, the real solutions are what are called the boundary points. Now, sometimes to get these real solutions, you have to do your own factoring. This particular example has the factoring done for you. So we just need to set each of our factors equal to 0. And then solve each one of these. Of course, this one we get x equals 0. Here we'll end up with x equal 3. And here we get x equal 5. So like I said, these are called your boundary points. Alright, step 3 says to locate the boundary points on a number line. So just draw yourself a real number line. Now, we're not going to go through and spend a lot of time putting a bunch of tick marks because actually 0, 3, and 5 are the only numbers we care about. You do need to make sure that you put them in order as they would be on a number line from least to greatest. And I put like really tall tick marks because I want these numbers to be the ones that really stand out. Okay, so that's what it means by step 3. Alright, step 4 said to choose a test value in each section and evaluate the function at that number. So just pick you any number that would fall into each one of these sections. So anything that would be less than 0. Now, there are numerous answers that are less than 0, so we're not always going to choose the same test value or test numbers as everybody else does. Anything that's between 0 and 3, and then between 3 and 5, and then anything that's bigger than 5. Now, you're going to take and substitute these test values back into the original, and that's not something that you have to show me. You can do it with your calculator, but what we're looking for is we're trying to figure out which sections are positive and which sections are negative is what we're looking for. So when I say take the test number, so like in this case the -1, so you'd come back and substitute it in for each of the x's and work it out and then see if you get a positive result or whether you get a negative result. Then we need to do that, like I said, for each one. Alright, with the -1, let's see. This is going to be positive. And then when I substitute +1 back up here, that's going to give me a negative result. And then if I substitute 4, I'm going to get a positive result. And then finally, if I substitute 6, I'm going to get a negative result. Now, a lot of the time, these signs do alternate. They do not have to. So don't assume that they will each time. You've got to make sure that you check, okay? Let me pull my steps back up here just a second and look at step 4. I mean, actually, step 4 is what we were just working on, where I chose a test value in each section, and then I evaluate the function at that number. So if the value is positive, then the function is going to be positive, greater than 0, for every x value in that interval. So if that one number in that interval gives you a positive, then every number in that interval will give you a positive. And then same thing for B part. If that one number gives you a negative result, then so will all test numbers in that section give you a negative result. All right, step 5 was to select the interval that satisfies the inequality. Well, this inequality says that you're looking for values that are going to cause your inequality to be less than or equal to 0. Well, the only thing that's going to be less than 0 that would make that true is going to be things that are negative. So if it's less than 0, less than or equal to 0, then you're going to go to the sections of your what's called your sign graph that are the negative sections. So that's going to end up giving you this section and this section. Now what we've got to do is just take this and write it in interval notation. So this section starts at 0, stops at 3. This section starts at the 5 and then goes to infinity. Now, the 0, 3, and 5 are the ones that make this exactly equal 0, and I am allowed to include those numbers because it's less than or equal to. Therefore, I would need to use a bracket for each one of these. So I'd have bracket, 0, 3, close bracket, put your union symbol, open bracket, 5 to positive infinity. So any number that falls in either one of these intervals would be a solution to this inequality. Okay, the next one. Now the difference that we have here is that we're actually going to have to do our own factoring. The one I just finished was factored for us. So to factor this, I'm going to start by factoring out a negative x. That would be a common factor, and I do want this to be positive, so I'm going to pull out a negative. And that would leave me then with x minus 1. Okay, so set each of those factors equal to 0. Okay, so I get x is equal to 0 and x is equal to positive 1. So again, that's what is referred to as those boundary points. And those boundary points are what we're going to put on our number line. So you're not always going to have the same number of boundary points. That will vary from problem to problem. Okay, now I've got to pick a test number that would fall in each of these sections. So I'm going to go with negative 1, 1/2 or 0.5 if you would prefer to write it as a decimal, and then positive 2. So again, you need to substitute these values back into the original and see if it gives you a positive or a negative result. Okay, with negative 1, that's going to give me a negative here. And then with 1/2, it's going to give me a positive. And then when I substitute in positive 2, I will have a negative. Now, this time my inequality states that I'm looking for any value that's going to cause my inequality to be greater than 0. Well, to be greater than 0, then you have to have something that's positive. So in this case, you're going to go with your positive section, which is just this one section that I have here in the middle. Now this time, my boundary points are not going to be included because 0 and 1, remember, is what made it exactly equal to 0. That's not what you need to have included here. You want just strictly greater than 0. So this would be parentheses, 0, 1, close parentheses. So anything that's between 0 and 1 would be a solution for this problem. All right, we're going to look at one more polynomial. Okay, so just like a while ago, what I've got to do first here is actually do my own factoring. And let's see, both of them would be minus. So actually when you set this equal to 0, of course the factors being the same, you know, all you're going to end up with as a boundary point is just going to be 1/2 this time. So this time just one number that I need to put on my number line. Okay, so test values, something that would be to the left of 1/2, so I could use 0. And then something that would be to the right, I could use +1. Again, you're substituting this back into the original to see whether it'll give us something positive or something negative. Now when I substitute in 0, I'm going to end up with a positive result. And then when I substitute in the +1, I'm also going to end up with a positive result. So this shows you what I was talking about earlier. It doesn't have to alternate, okay? So you've got to make sure that you check each individual section, because as you can see here, you've got each section being positive. Okay, so on this one, go into your inequality. You have greater than or equal to 0, and anytime that you're dealing with something greater than 0, you are looking for the positive portion. So that's actually each of these sections. Now what you've got to be careful about is, can you put it together as if it were all one big section? And that's just going to depend on if you can include the 1/2 or not. Now in this case, I can include the 1/2 because it includes those values that equal 0. So since I can include the number that separates the sections, that allows me to put them together all as one big section. So actually my answer on this one is going to be -infinity to +infinity. Let's just say this had been just greater than 0. So I want to use this same sign graph, but let's say this had been strictly greater than 0. That means the 1/2 can't be included. So if you can't include that, you just have to write it like it's two separate sections. So you would have -infinity to 1/2, because you'd use parentheses because the 1/2's not included. And then the other one would be 1/2, then to +infinity.